Hi everybody, it's Miss Austin and I'm going to be doing the Unit 5 Lesson 9 practice problems. We're talking about scaling the input, which is a horizontal scaling. All of these functions, we just need to figure out what the scale factor is right here. And to do so, we're going to figure out what scale factor was multiplied by this new input to get the original 10. So in essence, 30 times what number gave 10? Divide both sides by 30. We can see for this first one, it's a scale factor of 1/3. G's answers are the same as F 1/3 horizontally. So I'm going to write G of X equals F of 1/3 of X. Same thing here. I want to know, they switch on me, dash line. So my original function is right here. What did I have to multiply 5 by to get 3.125 to scale my input? I'm going to divide both sides by 5. I need a calculator. Oops, I know. 3.125 divided by 5, 0.625. G of X equals F of 0.625X. God, I hope you could see that first one. So sorry. The third one, what do I have to multiply? 0.277, my input on G, to get 0.693. Divide both sides by 0.277. .5 approximately. G of X equals F of 2.5X. And my last one here. This one we can kind of tell. Hopefully you can tell it's also been reflected. So here's my new function. What do I have to multiply? And I could have picked either point. I'm going to use this one. -2 times what scale factor to produce an input of 1? K equals -1/2. So I have G of X equals F of -1/2 X. Right, so that's technically a horizontal stretch and a reflection across the y-axis. Number 2, let f of x equal x times x minus 5 times x plus 2 times x plus 5. Decide if the reasoning about each of these following functions is correct. Andre says that g of x is obtained from f by scaling the inputs by a factor of 1. Scaling the inputs would mean multiplying every x by 0.1. Got multiplied by 0.1, got multiplied by 0.1, multiplied by 0.1, multiplied by 0.1. True. Each input was multiplied by 0.1. Claire says this graph is a vertical shift of the graph down 100 units. Well, the original function has a y-intercept of 0. Imagine if you put a 0 in here, right? It would get 0, 0. So this graph has been actually shifted up 100 units, not down. So this is not true. Letter C. Diego says that the graph of k of x equals -x times x minus 5, x plus 2, x plus 5 is a reflection over the y-axis. To reflect over the y, you have to change the input. All the x's would have to be negative. All that's happened here is k of x is just negative. There was one negative applied to f's original function. That's a reflection across the x-axis. So, Diego, this is not true. This is actually a reflection across the x-axis. A bacteria population in thousands is modeled by the function 30 times 2 to the d, where d is the number of days since it was first measured. The function g gives the bacteria population in thousands, w weeks after it was first measured. Express g in terms of f. Well, if I want to express this in weeks, that would be this guy, right, 7 days, and then times the number of weeks. So f of w is 30 times 2, I don't know why I put that, to the 7w. How does this compare to the original? If you look, right, the input has been multiplied by 7. So if I wanted to express this in a new way, not writing it like this, g of w is f, where I multiplied the input by 7. Number 4, the height of a hot air balloon in feet, m minutes after takeoff, is modeled by f of m equals 16m. How many minutes does it take for the balloon to reach 200 feet? So I'm going to put a 200 in. When is the output 200? Divide both sides by 16. 200 divided by 16. 12 and a half minutes. Another balloon takes off 5 minutes later and rises at the same speed. Write an equation for g where g of t is the height in feet of this balloon in terms of m. Well, all that's happened is I want to change the input by 5 minutes. So g of m is f's function, but 5 minutes later. So I want to do a horizontal shift to the right. So m minus 5. Sketch a graph of the two. Well, the original one takes off here, and then the other one takes off 5 minutes later. And I know it gets to 200 at 12 and a half minutes. So what is this? Or I'm just going to put, if I do 10, that'd be 160. So about right there. And then if I did that just 5 minutes later, that'd be like 210. Or sorry, 5 minutes later, so 15, it would be about 160. Just doing a rough sketch here. You could get some more accurate points if you wanted. Yeah. All right. Here's a function, or here's a graph of the function f, reflecting f across the x-axis and then reflecting across the vertical line y equals 1. Takes the graph of f back to itself. Tyler says this means that it is odd. Do you agree? In order to be odd, it's a reflection across the x and the y. So just for example, if I take this point, if I just ballpark it, that looks like 3, 8. It would have to be reflected down here to 3, negative 8. And then it would have to be reflected over here to negative 3, negative 8. Okay? This is not true. To be odd, it's a reflection across both the x and the y axis. And hope that helped, guys. I'll see you soon.